Hi, my name is Scott. I'm going to be a junior at Birchworth and Linux School, and this is the second milestone for my prosthetic hand. This is my prosthetic hand, and ultimately it's going to try to help people be able to write more efficiently. And this was my first real electrical engineering experience where I created and designed the schematics for the trigger, the electrical trigger, by myself. And so I learned the hardships of making your own trigger, designing the electrical schematic, because the current doesn't always flow where you think it is, and it's more difficult than I had previously imagined, but I made it. So this is my hand. The way the mechanical structure works is that you have a spool on the inside over here, and the tendon, which is fishing wire, wraps around the spool, which is around the motor, and it releases it or pulls on it, and that moves through a pulley system which pulls on the fingers. The reason why it has to work like this is because the motor rotates perpendicular to the way that the tendon needs to be pulled, and so by using a spool and a pulley system, you're allowing the tendon to wrap around here and pull parallel to the way the finger should be pulled and released, allowing the finger to move in that fashion. And so this is my electrical trigger, and the way this works is it uses a double pole, single throw, two of them switches, and the reason that this is more efficient is because when the power is turned on and the voltage and the current is allowed to flow through the system, it can go through one side of the switch and through the motor and around to the other side of the same switch, so that you don't have to use two different switches for both to move in either direction. You can just use one switch because the current will flow in a circle, and this is because it's double pull, single throw. Because it's single throw, these two move simultaneously, the two sides. So when you push down on here, both of these connect to both of these, so it's allowed to make a 360. And the reason that these two need to be in conjunction with each other, attached to each other, is because the positive side is here and the ground is here, and so it's able to move through this switch and back into here, and vice versa between the two switches. And the reason that this is taped together, these two switches, is because I accidentally broke off two of the sides, but I could still combine them together because there's no connection between these two poles. It's just between these two poles. Some of the problems I ran into is I did not isolate the two poles originally, so these two wires were connected together even when the button was not pressed down. And the reason that this hurts it is because if you have a connection without having to close the circuit, that can short circuit it, and it did. It shorted out, and so the battery burnt out, and I had to replace that. Also, I couldn't find, and I didn't have, a battery holster with 4 AA batteries, so I used 2 3 AA batteries and connected it in series, allowing for 6 volts to come through. And for the motors, I connected all 4 of these motors in parallel, which means positive to positive to positive, positive, and negative to negative to negative to negative. And the reason this works is because it's in parallel. Now the 6 volts gets to be evenly distributed between each of the fingers, allowing that to move. And this is the way it works. Turn it on. It's in conjunction with each other because I decided, for now only, to make one switch for back and forwards for each one of these, because for my final version, this is just to show that my fingers can move in conjunction with each other. As you can see, it's pulling on the tendon here. And this is my project. My next milestone is going to be my final video at BlueStamp, where I show that my hand is completed with a thumb and the casing around it.